Hey Year 7, today we're going through exercise 11E, which is on area of a parallelogram, which is quite a mouthful, but it's on page 644 of your textbook. So, parallelogram is actually a very interesting shape. Okay, so it's something that you guys probably haven't seen before, but if you have, awesome. So a parallelogram has 4 sides, so like a square kind of has 4 sides, same idea. And it has 2 pairs of lines that are parallel. Okay, so just a reminder, a parallel means that the lines will never meet, and they have these little arrows to signify that they are parallel. As you can see in this example over here, I've got 2 lines that are parallel right there, and they've got the 2 arrows over here to signify that they're parallel. So those 2 lines are parallel. If I get rid of that, so these 2 lines over here, these 2 lines over here are parallel, and these 2 lines over there are parallel as well. Okay, so that's what a parallelogram is, and it's in the name, which is why we call it a parallelogram. So the area of the parallelogram is found by using area equals the breadth times height. Okay, so it's a good idea that you actually write these down in your books, or at least highlight them in your book so that you can refer back to them when we have any assessments, or just if you're not quite sure what to do. So area equals the breadth times height. Now it's quite interesting because the base, or the breadth in other words, we'll just stick with base actually, the base times height is kind of similar to our rectangular formula. Okay, so if you look at this, I've got a parallelogram over here, and you can see that I've weirdly cut it, and the reason is because if I move this over here, you can see that, and it's cut off a bit of the line, but I'll draw that back in. You can see that the area is just base times height. Okay, so it's the same as a rectangle, just cut off a bit weirdly. As you can see, I'm going to do it again. I'm going to drag this across, and you can see that it's actually just a rectangle that looks a bit weird. Okay, with that in mind, let's get straight into the examples. So over here, I've got find the area of these parallelograms. So what I'm going to do is going to use the formula. Area equals the breadth times height, or base times height, sorry. So my base in this case is 12 meters. Remember, I'm referring back to this image over here. The height is 5 meters. And with that in mind, I can just multiply them. So A equals to B, which is 12, times by h, which is 5, to get my area. And remember, we're working with squared, okay? So it's 12 times 5. 12 times 5 is 60, and then meters squared. And that's it. That's how we find the area of that parallelogram. Let's go into the second one. This one's quite interesting because what I'm going to do is I'm going to rewrite this information over here and write it down over here. And you can see that, and there you go. You can see that the height is a little bit different from the base. All they've done is they've rotated this parallelogram on its side. Okay, so we'll say that this one over here is the base, and then we'll say that this one over here is the height. Remember, that's 3 centimeters. So my base is 2 centimeters, and that's from this one over here. My height is 3 centimeters, and that's from this one over there, or this one over here, doesn't really matter which one. And so from there, I know the area equals to base times height. So base is 2 centimeters times by my height, which is 3 centimeters. And that gives me a total of 2 times 3 is 6. So 6 centimeters squared. Okay, just a reminder, we're always working with whatever unit's squared if it's an area. All right, hopefully that made sense. If you have any questions, let me know.